All right, I'm going to give you a brief demo here with integrated circuits. And somewhere in your kit, you got a little piece of foam that has some stuff jammed in it. Most importantly, I want to call your attention to the two integrated circuits. This one here, I don't know if you can see, but there's a number on it. It says 74LS00. I'm going to refer to that as a 7400. I don't know exactly what letters yours will say, but one of them's going to say 7400 and the other is going to have a 7404. And yeah, you can see there's 7404 somewhere in that mix. Okay, so 7400 is NAND gates. That's N-A-N-D, NAND gates. The 7400, or the 7404 is NOT gates. So 7400 NAND, 7404 NOT. And you can look up all this stuff. I also wanted to call your attention to this little tiny divot right there. That's going to be really important. It's basically an indexing chip. And what it means is just as convention, when I put this on the breadboard, I'm going to make it face that way. And I hope to explain why. But bottom line is it's a big deal whether you mount it this way or this way, because the pins that you see online when you look up the pinouts, it's going to matter which way it's facing. So I'm going to start out with this 7400. What I'm going to do, I'm going to have it, and it doesn't matter exactly where, but I'm going to make it straddle the little channel there in the middle. And I'm going to move it way up here like that. Okay. Like that. Now, if you think about a NAND, if you think about a NOT gate, we give it 5 volts and it produces 0 volts out. If we give it 0 volts, produces 5 volts out. And part of your brain should be like, wait a minute, how is it I feed it 0 volts and get 5 volts out? Like, where does that come from? This isn't some like magic oil industry conspiracy or something. Really all we have to do is figure out where that energy is coming from. And so as it turns out, every single integrated circuit, every single little integrated chip has to be powered and it has to be grounded. So I've got some of my short wires here. And this, and you can see this on the pinout, but this, I'll hold it up here. This top pin up here is going to be power, and this one down here is going to be ground. And that's why I say it's a really big deal that we make sure it's facing the correct direction. So what I'm going to do is I'm going to run a wire from power to just somewhere there. And I got a shorter wire here. It's all right. Doesn't matter. Okay, that one's a little too short. So maybe it does matter. I got a different one. That's why I gave you guys lots of wires, because this sort of thing happens. Still digging around. I've messed around with my kit, so I've maybe lost all the wires, even though I told you guys not to do that. Anyway, big old wire. It's too long, but whatever. So now this chip's been powered and it's been grounded. And the way this works is, I'll try drawing it on here. It'll probably never show up on the video. There's basically a little NOT gate that goes between those two pins. And actually there's multiple of these on here. So there's another one here, another one here, another one here. Should have 6. Anyway, so what's going to happen is this one is going to be our input. This one's going to be our output. So for output, really simple output for logic gates, is a nice little LED. Because if it lights, we know we had a true signal. If it doesn't light, we got a false signal. So what I'll do here, check to see which side is there. Okay, so I'm basically from the output, putting an LED from there to ground. Then what I'm going to do is I'm going to make a switch wire. And this sounds a little weird, but what I'm going to do, there's a lot of things that go into electrical switches, and we'll talk about that later. But for what we're going to do now, I've just got this piece of wire. I'm going to stick it in the input. The nice thing with the new breadboard is all of the little springs that hold these wires in are nice and strong. The bad thing is they're also nice and strong because they tend to bend the wire if you're not paying attention. So maybe you should have something like this. I don't know if you can see that very well, but there it is. So this is going to be our input. The LED is going to be our output. And now what we're going to do, I'm going to connect the battery. Whether or not it lights right now is not super important. Make sure all my connections are in. But what is going to be important is I'm going to take this wire and I'm going to input 5 volts. Notice the light stopped flashing. It, went out like we would want it to do. So I input 5 volts. I input a logic 1 and got a 0 out. That's what we'd expect from a NOT gate. Now, I take my wire out. I'll plug it into ground. And now I'm inputting 0 and I'm getting 5 volts out. That's why the LED is lighting. Input a logic 1, I get a 0 out. Input a logic 0, I get a 1 out. And if flashing in between, we'll talk about that in a later lecture. But that's how you know the NAND gate works. So that's what I wanted to show you today. Common problems, I'll go through this real quick. Common problems are if you mount this chip backwards, you're connecting power to ground and ground to power, and that's how you let all the magic smoke out of the chip. It'll get really hot and you'll say, what's going on? And eventually there'll be a little puff, and that'll be that. And then you'll have to send me an email about it. If it doesn't work either way, check all your connections, but also make sure your LED is facing the correct direction. So very first thing, even before you connect the battery, make sure that the notch is facing this way and that this is your power and this is your ground. So make sure it's powered and grounded. Still doesn't work, flip your LED and make sure it's facing the right way. Still doesn't work, go check all your connections. If you really wanted to, you could build another one on some of these others. And the idea being that there's multiple NOT gates on here. So there it is. I will show you more in another video.